Hi netizens, it's Math Magics by Andy Wonder. Quick one. I have longitude and latitude. The question reads, does calculate the distance between 2 points. Point P is what? 40 degrees north, 22 degrees west. And point Q gives us 28 degrees north, 22 degrees west along the longitude to 3 decimal places. What are longitude lines? Longitudinal lines have to do with those imaginary lines that run from the north pole of the earth's surface to south pole. What about the latitude? Of course, there are also imaginary lines that run from west to east. So to get this solution, all I need to do is, our people say seeing is believing. So I need to illustrate this diagrammatically for clear understanding. This is the Earth, which we show on a globe. Here happens to be the North Pole and the what? South Pole. Here becomes the equator. You need to understand that all longitudinal lines are great circles. Why are they great circles? They are great circles because every great circle divides the earth into two equal parts. So if you have longitudinal lines like this, we consider these ones as what? Great circles. So that is what we need to take note of. Then the latitude, the lines of latitude are small circles because they do not divide the earth into equal parts except the equator. You can see the equator here. So this actually divides the circle into equal parts. So if there is a question maybe that has to do with which latitude line happens to be a great circle, that becomes what? The equator. So in this case, let's go through the question. We have the 40 degrees north. Let's start with the latitude. 28 degrees what? North. See the northern part here, and this is the southern part. Of course, we are having the east and we're having the west. At this point, if you are referring to, from here down to this place, you have about what? 90 degrees. Of course, this is 40 degrees and this is the side of the north. We understand that 40 degrees is not up to what? 90. So by the time we assume, we can take our 40 degrees north to be somewhere here. So here becomes our what? 40 degrees north. Then 28 degrees north. 28 degrees is below 40 degrees. So we can take it somewhere here. So here becomes my what? 28 degrees north. Looking at the diagram, you can understand that we've shown the location of what? The latitude. Then there's something I want you to take note of. If you are to show the location of the latitude, which I have actually done here, there is something you need to understand. In latitude, you must reflect that of what? North and what? South. You can see it. For the line of latitude, this moves what? 40 degrees north, 28 degrees north. But the line is what? Latitude. It's a latitudinal line. So now, what if you have that of the longitude? It is time for we to show the longitude. All we need to do is to reflect that of what? West and east. So in longitude, you think of your west, then your what? East. So this will enable you understand how the locations are being shown. Um, 22 degrees west, 22 degrees west, that of the longitude. This side is your east, this side is your west. So we are illustrating it down the side. Um, down here, then here, down to this place. Now, where is the point? The point, the longitude and the latitude, see, this is where the point intersects. So this becomes, where is 40 degrees? 40 degrees is in point P. So this becomes my point P. Then where else did they intersect? Here. So this is where they intersected. 28 degrees is in point Q. Here becomes your point Q. Of course, this is a case of a great circle because the lines move through the words, the line of longitude. So it is a case of great circle. This refers back to what? The equator. You know, equator is also a great circle. In this case, it is now time for we to show the distance. To calculate the distance, we understand that in latitude or even longitude, so we are talking about latitude here, if they have the same pole, what do? You subtract. But if it has different poles, you add. 40 degrees north, 28 degrees north, the same pole, north, north. So what do? We have to subtract the poles. This becomes 40 degrees minus 28 degrees. That is 12 degrees. So this is a case of what? Great circle. Then when it is a great circle, we recall that the distance will be theta over 360 degrees times 2 pi r. I know what this r is. This is the radius of the earth. And having understood that we are treating a great circle, then we will use capital letter R. And the radius of the earth is what? 6,400 kilometers by approximation. So this is the radius of the earth, and this is what we'll plug into the equation. The difference, remember, we are having 12. So to solve this becomes 12 degrees over 360 degrees. Do not forget, 12 degrees is gotten through the difference of the what? Poles. 40 degrees minus 28 degrees, that's how I got 12 degrees. Then times 2 times pi, which is what? 22 over 7. Then times radius of the earth, which is 6,400. We proceed. 12 in itself is 1. 12 in 36 is 3. Bring down 0, which is 30. 2 in itself, 1. 2 in 30, you get 15. So I'm having 22 times 6,400 divided by 15 times 7. I will have 1 over 15 times 22 over 7 times 6,400. To punch this in our calculator, we have 22 times 6,400 divided by 15 divided by 7. By approximation, this becomes 1,340 points. How many decimal places? 3 decimal places. 9, 5, 2. kilometers. So this becomes the distance between this point P and point Q along the longitude. This becomes our final answer. Please like, share. Bye bye.